Let's look at some Lewis structures that will result in compounds having multiple bonds, double or triple bonds. And these compounds require multiple bonds because they're electron deficient. If you haven't read the preamble material at the top of the page, you need to go ahead and do so and pause this video. In drawing Lewis structures, the first thing we always have to do is determine the number of valence electrons. So we're first looking at molecular nitrogen into diatomic nitrogen. Group 5, we have 2 nitrogens, that means we have 10 valence electrons. The only possibility for a skeletal structure is to bond the 2 nitrogens together. We've drawn in 2 electrons, that means we have 8 left to draw. So there are 2 ways of going about doing this. One of them is to draw in those 8 electrons that we have. Now we've drawn them all in, we don't have any more to draw. If we try to get an octet for each nitrogen, the nitrogen on the left only has 6 electrons, 2 from the bond and 2 from each of the lone pairs. The nitrogen on the right has 6 electrons, 2 lone pairs, and sharing the bonding pair. So what we can do is take a pair of electrons from each and put those in for bonds. So if we do that, there's my skeletal structure. My 2 electrons on top of the nitrogen on the left, and we'll put in as a double bond, and the 2 electrons from the nitrogen on the right that I showed come in to make a bond. And that leaves me 2 electrons in each nitrogen, a lone pair. And so that will wind up being the correct Lewis structure. Each nitrogen has 8 electrons around it, or an octet. We've drawn in 5 pairs of electrons. 1, 2, 3, 4, 5 pairs, which corresponds to the 10 valence electrons that we have. The other way to have done that is to, if you don't like drawing in the dots and rearranging them, draw in the 2 nitrogens. We have the 10 electrons. Drew in 2, that leaves us 8. Just count up the number of valence electrons each needs to finish an octet. That nitrogen needs 6 because it's drawn the 1 bond with 2 electrons. That nitrogen needs 6 because it's drawn with 1 bond and 2 electrons. So in all we need 12 electrons, which means we're 4 electrons short, or 2 pairs of electrons short. For every pair of electrons short, you draw in an extra bond. So we're 4 electrons short, that's 2 pairs. We need to draw in 2 more bonds, which will yield the triple bond. And then if you give enough electrons around each nitrogen to give an octet, you'll have the correct Lewis structure. Carbon monoxide. Carbon's group 4, oxygen's group 6. Means we have 16 electrons to show in our Lewis structure. No more, no less. Keeping symmetry in mind, and also electronegativity, that the least electronegative atom typically goes in the middle. Carbon will go and be the central atom, to which will bond the 2 oxygens. Each bond represents 2 electrons. We've drawn in 2 bonds, each worth 2 electrons. We've drawn in 4 electrons. That means we only have 12 left to draw. So we can start drawing them in. 2, 4, 6, 8, 10, 12. If we do that, the carbon has an octet. It's got 4 sets of electrons around it. Each oxygen, though, has a single bond, that's 2 electrons, plus 2 lone pairs, or non-bonding pairs, each with 2 electrons. So each oxygen only has 6 electrons. Both electrons are short 2 electrons to give an octet. So we can take a pair of electrons off of each and make a double bond out of it. So redrawing that, the oxygen on the left has lost 2 electrons, still has 2 left on it. The oxygen on the right has lost 2 and still has 2. So that's one way to come up with the Lewis structure. The other way is go back to where we have our skeletal structure. We got 12 electrons left to draw at that point. You just count up the number of electrons needed by each to complete an octet. Carbon needs 4, oxygen needs 6, oxygen needs 6. So we need 16 electrons. We only have 12. We are deficient 4 electrons, or 2 pairs. For every pair of electrons, you draw in an extra bond. So you got a choice. You could draw in a triple bond, or you could draw in a double bond. Nature loves symmetry. That will rule out that particular structure. And we also know from experimental data that there are 2 carbon-oxygen double bonds in the molecule as opposed to a triple and a single. Now if you give every atom an octet, that will be the correct Lewis structure. The carbon has made 4 bonds. It has its octet. Each oxygen has made 2 bonds, has 4 electrons. Each oxygen needs 2 lone pairs. And that will be the correct Lewis structure. We've got 2, 4, 6, 8, 10, 12, 14, 16 valence electrons. No more, no less. The next one, carbon monoxide. Carbon group 4, oxygen group 6. That gives us 10 valence electrons. The only possible bonding arrangement is to bond the carbon to the oxygen. We've drawn in 2 electrons. We have 8 left that we can draw. So let's put 4 on each atom. When we do that, and see if the atoms have an octet, each atom has 2 non-bonding or lone pairs, so that's 4 electrons, plus they share the single bond with 2 electrons, so the carbon and oxygen atoms have 6 electrons. They're too short, each one of them. And so each one needs to contribute 2 electrons to make another bond. So we take 2 electrons from the carbon, makes a double bond, 2 electrons from the oxygen, gives us a triple bond. And we have 2 electrons left on each of those atoms. And that gives us a triple bond for carbon monoxide. C2H4, carbon group 4, hydrogen group 1. 2 carbons bring in 8 valence electrons. Each hydrogen has 1 valence electron. We've got 4 hydrogens. That means in our Lewis structure, we have to show 12 valence electrons. No more, no less. So the central atoms are going to be 2 carbons, to which we're going to bond 4 hydrogens. That being the case, we've drawn in 1, 2, 3, 4, 5 bonds. We've drawn in 10 electrons. We can only draw in 2 more electrons. And so the hydrogens are happy. They've all made their 1 bond. The carbon on the right has 8 electrons, 2, 4, 6, and then the non-bonding pair. The carbon on the left, though, only has 6 electrons. That violates the octet rule. It's electron deficient. So we're going to take 2 electrons from that carbon and make a double bond. And that will be the correct Lewis structure for C2H4. C2H2, carbon group 4, 8 valence electrons in all. Hydrogen group 1, we got 2 of those. Now we've only got 10 electrons. The central atoms will be carbons, to which we will draw hydrogens. So now we've drawn in 1, 2, 3 bonds. We've drawn in 6 electrons. We can only draw in 4 more electrons. So if we put 2 on each carbon now has just 6 electrons. The 2 bonds each carbon is made, plus the non-bonding or lone pair of electrons. Each carbon is deficient 2 electrons. To get around that, we'll draw in 2 extra bonds. Oops, lost a carbon in there. So there's my 2 carbons, each bonded to a hydrogen, and now we've got a triple bond. So if we count those up, single bond, triple bond, single bond, 5 bonds, each with 2 electrons, total of 10 electrons, and that's what we're supposed to have. The last one is the cyanide ion, Cn minus. Carbon group 4, nitrogen group 5. From our atoms, we got 9 valence electrons. This ion is an anion, it's got a negative charge, which means we've added an electron. So that means we need to show 10 electrons. We'll bond the carbon to the nitrogen. We've drawn in 2 electrons. That means we have 8 left to draw. So 2, 4, 6, 8. However, each atom is deficient in 2 electrons. The carbon has the 2 lone pairs plus the single bond, that's 6 electrons. The nitrogen has a single bond plus the 2 lone pairs, it has 6 electrons. Each atom's deficient in a pair of electrons. So if we move a pair of electrons from each atom, we can make a triple bond. That leaves a lone pair on each of the 2 atoms. So we'll wind up with 10 valence electrons in our skeletal structure. 10 electrons was what we could start out with. And so if you stop for a moment and pause, you can notice that back in carbon monoxide had 10 valence electrons with only 2 atoms. That gave us a triple bond. The cyanide ion, 2 atoms, 10 electrons, that gave us a triple bond.